Hi, this is Mike of 71 Squared and welcome to the second tutorial on writing a game in OpenGL on the iPhone. So at the end of the first tutorial we had covered creating our basic project. So we were actually able to print a sprite or an image onto the screen using OpenGL. And we'd used a couple of things to do that. We'd taken the standard template OpenGL application template in Xcode and we'd made some changes to it so we could use that, and we'd also imported the texture 2D class that Apple had created or used within their crash landing example, and we used that. Now going on, what we want to do is we want to actually do more than just print something to the screen, otherwise our game's going to be pretty boring. So what I decided to do was, while texture 2D was a cool class, it did what we needed. It was able to take any image that we handed it and turn it into an OpenGL texture, dealing with all those things like the power of two sizes and stuff like that. It's really not flexible enough for what I want to do in my game. I want to have simpler, easier methods to be able to use to rotate images, scale images, maybe apply a color filter, those sorts of things, and also be able to get sub-images. So maybe I've got a large texture but I only want to draw an image which uses a small part of that texture, so getting a sub-image. So they're things that I'm going to probably need to be able to do in my game. So what I've decided to do is to actually create a class of my own which will do that for me. So we will still use texture 2D in the background as the image loading class, if you like. So that's what we'll use to load an image and turn it into a texture. But when it comes to actually rendering that texture and storing information about a texture on the screen, we'll use a new class called image. Now the other thing I wanted to do was to, obviously I've been writing some of these classes in the background just so that I can see how they're going to fit together for when I come and do my tutorials. So I wanted to give you an example of where we are and the kind of things that we're going to be able to do once we've finished the tutorials that we're working through at the moment. So I'm just going to run the simulator now, and this is going to show you a small test application that I've got running that is demonstrating some of the things that we're going to be creating. So what we can see here is that I've got my image that we actually displayed at the end of tutorial 1 in the middle here, but I've also now got the ability to be able to scale and rotate it. So I've got the same image below, but I've scaled it to 2 times normal size. I've also rotated it through 180 degrees, and I've applied a color filter to it. So you can see the color has changed from the original, and I've also made it slightly transparent. So these are all things that we want to be able to do through the image class, and this is an example of that. Once you can do those sorts of things, you can then start to do animation, which I've got up here with these two. So this is just showing a very simple animation being run through of a rotating disc. And over here we've got an animation playing, but at the same time as just rendering the animation, I'm actually rotating the animation as well. So this little guy here rotating around, that's not part of the animation. That's me actually rotating the image as I'm actually animating as well. So these are things that we need to be able to do. So once we've built our image class, we'll then be looking at building a sprite sheet class to be able to handle access to different images within a sprite sheet, or a texture atlas as some people call them, and also then we'll be looking at animation so that we can actually start to animate them and put lots of images together in like a flipbook type approach, which is what we're doing here. And then lastly, the latest class that I've worked on is one around text. So you'll see here that the scrolling message at the bottom of the screen going past, and also this time at the top of the screen, it's not using fonts that are available on the iPhone. What this is doing is actually using bitmap font. So I've got an image that represents every letter and number and value or character, if you like, that you can use, and you can then render a string to the screen, and you can use one of the fonts that you've created, and there's tools around that. And that's something we'll cover in more detail when we actually look at creating this bitmap font, if you like, class, which I'm using here. So these are the kind of things that we're playing with, and as you can see and imagine, this is going to give us the basis for being able to write our game. We can move things around, we can scale them, we can animate them, we can have text on the screen in any sort of shape and size and style and colour that we want. So once we've got that together, then we can start looking at how do we actually create a game and how can we start getting our little guy to move, how can we actually start firing and so on. So I know I was going to try and cover getting to the guy to move in this tutorial, but decided that actually I needed to finish off building out the classes to do what you're seeing on the screen now. Then we can start thinking about other game mechanics like moving the character and actually controlling entities on the screen. So hopefully that's given you an idea of the kind of things that we're going to be building up and towards at the moment. So if I now actually go and load our tutorial, sorry. So the other thing you'll notice is that I made a bit of a mistake in the first tutorial. I went and called our project Tutorial 1, which was great for the first tutorial, but doesn't really make a lot of sense for tutorials 2, 3, 4 and 5 and so on. So what I've done is I've actually taken that tutorial where it was at the end of the tutorial, that is, and I've created a new project with a name called OGL Game. This is available on the blog, so that you can actually download this and carry on and follow along with me. But this is going to be the project that we actually build each tutorial into, rather than having a project called Tutorial 1. So I learnt from that, and this is how we're going to move forward. So if I open up my project here, this OGL 1, okay, so this is exactly where we finished off the tutorial, the first tutorial that we covered. And if I actually run this, you'll see that all we get is our little ship in the middle of the screen. So that's where we were, okay? Now what I'm going to do is, as I run through this, there is obviously quite a lot of typing involved, and rather than actually have you sitting there watching me type, I'm going to actually just copy in the pieces of code as we go through and then describe them, and we'll give that a go and we'll see how that works. And that'll save me typing this in. You'll still get to see the code, you'll still get to hear why I've done it and what the code is doing, but it just saves me typing it all in, which will hopefully speed things up and not take up too much time. So as I said, we are going to create a new class, and we're going to call this class Image. So because we're going to create a number of classes, we're going to have one covering image, one for sprite sheet, one for animation, one for my bitmap fonts. I'm actually going to create a group called Engine. Okay, so I'm going to have a new group, and this is going to be called Engine, because this is really sort of the game engine. This is the fundamentals of what's required to make our game work. Within here, I am going to create a new file, and this is going to be our image class. So it's a NSObject subclass, and we're going to call it image. Okay, so there we go. Now, what we need to think of is, what are the kind of things that we need to store to actually have our image? There's a number of different properties we'll want and that are important about our image, and we need to define these things. So what I'll do is I will now paste in the code that defines the properties that we need here. Okay, and there we are. So if I just run through these, we need to be able to reference a texture. So remember I said texture 2D is going to be the underlying texture that we use. So we need to be able to reference that, and we're going to call that texture within this particular class. We then want to know what the image width and the image height are, and these are the actual widths of the image itself. So in other words, when we've loaded something in, the image is now going to be of a particular width and a particular height. And this is going to be using this power of 2, where we actually have, if we take, for example, my graphic, the little ship that we've been displaying on screen, that's 47 pixels wide by 71 pixels high. So the actual image size, or the texture size, which Texture 2D will have actually created for us, to accommodate 47 pixels, the next power of 2 figure it could use is 64. So the actual image width is 64. The height of our image is 71 pixels. The next power of 2 value that could handle that is 128. So our actual texture size that has been created by Texture 2D is 64 pixels wide by 128 pixels deep. And that's important. We need to know the size of that new image, if you like, for our calculations. And that's what's being stored inside the image width and the image height. I have a bit of a cold, so excuse me if I cough or sneeze through this. The next things we have are texture width and texture height. So I've just described that our image width and our image height could be larger than the actual texture inside it that we want to display. So the texture is actually held as a number from 0 to 1. So 0 being the left-hand side of the texture, 1 being the furthest right-hand side of the texture. And it's the same for the height. So if we had an image size that was 128 by 128, but our texture, the actual image we wanted to display, was only 64 by 64, then it would mean that our texture width would actually be 0.5. In other words, it's halfway across the entire texture. So the whole texture is 128 wide, our texture is only 64 wide, so getting access to the right hand side of it would be a value in texture width or texels of 0.5. Same for the height. Again, that's going to be handy for us to hold that, so that we can actually, for an image, when we render the image, we can have very easily specified exactly where we want that image to be taken from our larger texture. So texture width and texture height are going to be doing that. We then have our max texture width and our max texture height, and this is important because, as I said, 1 is the furthest right hand side of our image, but if our image isn't that big, it's only 64 pixels wide, something like that, we want to know, well, what's the maximum texture width that we can have, which would be 0.5 in that instance. So we're going to store those as well. We then have something called the texture width and the texture height ratio. And these are just values that are calculated and that we can use later on. So if we know that the width of our image is 128 pixels, we can then say 1 divided by 128 gives us a ratio. So it tells us how many real pixels we need to, or how many real pixels are, let me just describe this, I'm not describing this very well. If we have 0 to 1 is the texels, okay, 1 being the right hand side, we need to understand how many texels relate to how many pixels on the screen. So what 1 pixel in our image relates to 1 texel in our image. So that's what we need the ratio for. And that means that we can do the width of the image divided by 1, and that gives us our ratio. So we can use that. If we want to get 50 pixels across in our texture, we can say 50 multiplied by the texture width ratio, and that will give us our texel value in how far we need to come across the image. So again, they are useful values to have inside our image to actually be able to really specify where we want to print things out. I've then created something called a texture offset for X and Y. And again, we may have a texture in our image that is a large texture, but this particular image actually is only going to be referring and printing a small part of it. So being able to set an offset on the X and the Y axes, and then just saying, you know, print the image this wide and this high from that offset is a useful thing to be able to do. It's going to speed up when we're actually rendering our image to the screen, in terms of we're not going to have to do the complicated calculations ourselves. So that's in there, and these things will probably make more sense as we actually start to use them. We also have at the end here rotation. So I want to be able to store the number of degrees of rotation that should be applied to the image. We have scale. I also want to be able to store the scale of the image. I want to be able to scale it up using a positive float value, and I want to be able to scale down using a negative float value. And I also want to be able to apply a color filter. In other words, I want to be able to apply a color to the image as it's displayed using red, green, blue and alpha. And to do that, I'm using a float array with 4 possible locations, 1 for red, 1 for green, 1 for blue, 1 for alpha. So that really sets up quite nicely our properties that we need when we're actually dealing with an image. So once we've set those up, we then need to apply all of the necessary getters and setters for those particular properties, which is what I'm going to add now. Excuse me, which is what I'm going to actually stick in here now. So if I pop the getters and setters in. Okay, so this is really straightforward. We would have seen this before. Some of these are actually marked as read-only. So the texture width and the texture width ratio, they are calculated when we create our image, and we don't really want to change those because we're not going to let an image has a reference to a texture, and we're not going to let that change. If you want a different one, you create a new image. So these things we can read them, but we can't actually change them. The others we're just doing getters and setters, so we can get and set the rotation, the scale. We can actually get and set the image height and the image width. And again, in fact, image width and image height are probably things that that we need to say are read only. So I'm actually going to just stick in read only here. Okay, because they are defined during the initiation of the image and won't get changed by any external software as we go through. Okay, now one thing I do want to add to the top here are some notes, some comments that I've created. And what I'm trying to do with these comments is just give you something to be able to read and understand a little bit more about how texture mapping works and how the textures are mapped. So if I paste in this rather large comment area here, okay, and my little picture here has sort of not worked quite as planned. So let me just move these in a bit. So this is just this was just a little diagram here to try and show what the important things were inside my. Okay, here we go. This was really just to try and show what I was talking about earlier in terms of what pixels relate to what items inside an image when it comes to the texture and so forth. Okay, so that's looking a bit better. Okay, that's a little bit better there. So what this little diagram here is saying is that we may have, and I'm using my my player.png picture as an example. Okay, so the player.png picture was actually 48 pixels wide by 71 pixels high. And that actually, because of the power of 2 rule, meant that we ended up with an image being created, or a texture being created by Texture 2D that is 64 pixels wide and 128 pixels high. So that's our texture width and that's our texture height as we've defined in our properties. Our image width is the actual width of the image itself that is inside there. Okay, so the texture width is the width and the height of the texture. The image width and height is the width and height of our actual image inside that texture. As you can see, it's not taking up all of the space that has been created in that texture. Because of this, you do have to think carefully about your graphics and about how you use them. You don't want to waste too much texture memory by having unused space like this, which is really where sprite maps and texture atlases are important, because you could end up having this image plus maybe another image underneath it and maybe a set of images down here. And you could use those and reference those as you need to inside a single image. So those sub-images inside a single image mean that you're making best use of these spaces. So you're packing together a number of different images in a single image, and then you're going to reference them as sub-images later on. So if we can reference them as sub-images, we can then save quite a bit of texture space by packing them all together. There are tools out there that actually let you pack images together and give you like a little control file which you can use to work out where the images are within the overall larger image. And that's probably something I'll cover later on in another tutorial. And maybe we can even have a go at creating our own little application, maybe a desktop application to pack images together and give us a control file which we can then consume inside our little game engine here. So this little diagram and the words here are really hopefully just describing you know, how I am actually doing the calculation of these values and what the values are used for. And this is really going to teach you, or at least show you, how the texture mapping is working. In other words, how are we actually mapping a texture from an image onto the image that we're drawing. And what you'll find happens is that you define a couple of things as we go through here. You'll define the texture coordinates, in other words, the coordinates you want to use inside this texture. And again, it goes from 0, 0 in the bottom left-hand corner to a maximum of 1 and 1. Okay, we've said before, that's what we would use our text cells for. So you define those coordinates, you then define your quad coordinates, in other words, the coordinates for the box you're going to draw. And if the box you're drawing is larger than the dimensions of the image that you're mapping inside it, it will actually zoom up the image to fill the box. And that's how we're going to scale. It's really that simple. It will say, if you've got a box that's twice as big as the image that's filling it, or any sort of ratio really, it will actually scale that up and down for you, and stop you having to worry about doing the scaling. It just scales, so it does the same down, does the same up. And we'll cover off a little bit about that as we actually go through the tutorial and look at the code that's doing that. But it is really, really straightforward. So I'll leave you to have a look through those notes inside the project that you'll find on the blog, and you can have a read through, and I'm hoping that sort of will just make a little bit of the texture mapping side of things a little easier to understand here than sort of me trying to just describe it. Okay, so if I now have a look down at the bottom of our code, we've got our properties and we've got our properties set and the getters and setters. There are now going to be a number of methods that we need to create to actually do the work inside our method for us. So, excuse me, I've broken these down into some different areas. What I've got here is some initializers. So these are methods that are going to allow us to actually initialize the image. And I've got a few of them you can see, and these are just really to help us when we're initializing some textures. So the first two that you can see here in the list are actually initializing an image with a texture that's already been defined. Oops. So if you've already defined a texture somewhere already and you want to use that texture inside your image, rather than creating a brand new image and therefore it creating a brand new texture in the background, which is doubling up the amount of memory you're using in texture memory, you could just reference, if it's going to be around for a while, the texture you've already created. So in this particular example, that's what you can do. You can actually initialize a texture or an image with a texture, and you pass in the texture that you want to use to initialize. The one underneath does exactly the same, except this time it's also taking in a scale variable as well. And what will happen is that the image will be defined using that scale. So in other words, if you want to have something that's twice, when you print it out, twice as big as the texture you're feeding in, then you can put in a scale. We're then doing the same for image. So the next ones are really covering the creation of an image from a UI image. When we look at the code inside here, you'll see that what's actually happening is that we're creating a new instance of texture 2D with that image, because that's doing the creation of our texture for us with the power of 2 stuff going on. But inside our image class, we don't really want to worry about that. So we're just saying pass in a UI image and we will create an image from that. And again, there's just 3 little convenience methods underneath here as well. So the next one allows me to create an image from a UI image, but also to apply a filter. Now, when we talk about filters, there are a number of different filters that can be used in OpenGL, but this one is really around what I was discussing a little earlier, was that if you zoom up an image, in other words, you place a texture inside a shape or a quad that is larger than that texture, it will actually zoom up on that texture and increase its size. And it will use filters to do that. I'm only interested in a couple of filters, one called GL Linear and one called GL Nearest. GL Linear means that it will actually try and create a nice smoothed copy. So it'll be bigger, but it'll be smooth. It won't be pixelated. It'll just, using the filtering technique, it will actually try and blend it and smooth that to give you a nicer looking zoomed up image. That's GL Linear. GL Nearest, when it zooms up, it just pixelates things. So if it just makes everything look quite blocky when it's zoomed up. And there are good reasons for using that sometimes. And when we get into animation, you'll see why that can be important. But I wanted to have the ability of being able to, when I create an image, define whether it was going to be filtered linear or it was going to be filtered using GL Nearest, so that I can change that on an image by image basis. So I'm feeding that in here. It's using GL in enum, and that's really just an enumerator that's defined as part of OpenGL, and it does allow me to use things like GL underscore nearest and GL underscore linear, and that's why I've used that. I then say I want to create an image this time with a scale, so I can pass in the scale just like I did with the texture, and it will create the image at that scale. And I can then do the same again, except I can pass in scale and filter. So it's just, as I said, convenience methods to really help me and sort of save code when I'm creating images. The next methods that I sat down and thought that I would need are around actually actioning something. So in other words, I need to be able to render things to the screen. So if I just paste in the next set of images here, you can see that the first one is called get some image at point, and it returns an instance of image. So what this will do is, if you've got an image already, but you want to create a new image, which is just referencing a small subsection of the original image, you can use this particular method. And it's very simply, you pass in a CG point, which is the X and Y coordinate of where you want to take that sub-image from. You then say how wide that sub-image should be, how high the sub-image should be, and if you want to scale that sub-image, so you can scale it at the same time. And what you'll end up with is a new image instance, which will provide the, or if you just rendered it to the screen, it will just render that sub-image portion that you've identified inside this method call, which again, really useful when we get to sprite sheets and animation. You've got the core one here, which is I want to be able to just render at a point. I want to be able to take the image and just render it on the screen at a certain point. So point is a CG point, as you would expect. And I've also added an extra little variable here, which is called center of image. And this, again, is something that can be useful. If you render an image to the screen, you may want to actually have the center of the image located at the point that you've provided, which can be quite handy. Or if it's not at the center of the image, in which case you would say no as the value here, because it's a Boolean, then it would actually be located, the point would be located at the bottom left-hand corner of the image that's printed. And as we go into the bitmap font side of things, again, it's sometimes important to always print things using the bottom left-hand corner, regardless of the size of the image, and we'll go through why that's important. The next one is that you may want to be able to retrieve a sub-image from an image, but you also may want to just render a sub-image at a certain point. So you don't want to have a new copy of this image, but you just want to render a sub part of this image at a point on the screen. So I've created a method here called render sub-image at a point. And again, just like with the get sub-image, it takes a point where the actual rendering will take place. It takes an offset point, which is the X and the Y of the offset that's required. It then takes the image width, the image height, and also it takes whether you want to, again, render using the center of the image or the bottom left-hand corner of the image. Okay, so they're pretty straightforward. We're going to go through the code for these in a second. The last things that I actually want to create in here are just a couple of setter routines. So if I just paste these in, I know that we've got an array up here, and I could just have an array passed in and use the normal setter routine that's created by doing a property on it. What I'm actually going to do is I've just created my own couple of simple methods here. Set color filter red, green, blue, and alpha. It does exactly what you would expect. It sets that array based on the values you have, and so that's then the color filter applied to this particular image. Or set alpha, setting the transparency, can be set on its own as well, because alpha, you may not want to have to go through setting the colors all the time. You may want to just set alpha on its own to make something semi-transparent or transparent. So I've added another setter routine there to do that. So that really, if we save that now, that really gives us our header for our image. We've defined our properties that are important to us. We've gone and done the property assignment so that we can get our getters and setters as we require. And we've also gone and initialized the headers for our methods inside here. So what we can do now is we can go into the actual M file of image and start to create the guts of what's going to go on inside the image side. So I'm going to highlight that. It's pretty empty at the moment. So we're going to start to fill this out with the code that we need. Now, to start off with, we need to do our synthesizes. So we did all those properties on the previous page. So we need to actually synthesize now those properties on here. So I'm going to paste in the synthesize. You can see that these are just an exact copy of those items that we had before, so that the getters and setters are set correctly. And then what we need to do is we need to start dealing with those initialize methods. So if we go back here, we had these initialize methods that we said we're going to need to create. So we need to go through now and create the actual methods behind each of these. So the first one that I normally do is I normally have just a standard init, which is really just habit more than anything. But what I do is I have an init method which really just initializes this and sets all of the different properties with a default value, so that the object in memory will function to some degree and shouldn't cause too many problems. So if I just paste that in here, we can see it's just a standard init routine, which every object really should have. And then I'm just defaulting in the values for each of the different properties that are important here. Okay. So because I haven't got an image or anything like that, I'm just literally saying that everything in here is going to be defaulted to some very simple value. Okay, so once we've done that, the first texture or the first init that we had was a texture. So if we look at the class which we're going to use for doing that, okay, here's our init with texture. So we're taking in a texture 2D object, and inside the initialize routine, I'm actually going and setting the texture object inside, or the texture property inside our image to reference text. So that is a pointer. Okay, this isn't going to be creating a copy of this texture, it will be referencing that texture. So if that external texture was ever removed or deleted, then this image would also fail to work as well, because it's lost its reference to that. So you need to remember that when you're deallocating anything that you've created and you've actually passed this into it. Because the texture is external to this image class, if it's removed, this image class is only referencing it, and therefore there'll be a problem. Also, because I'm not actually taking a scale in here, I'm defining scale to be 1, so it's going in with the same size as it is. And you'll notice that I'm calling a routine as well called init imp, or init implementation. And this is just a way of all of the other things that need to be set when you actually run an initialization. Rather than repeating them inside every single one of these convenience methods, I have another method that gets called that sets all of those objects as well, called init imp, and we'll implement that in a moment. So if I just carry on here and move through, so that's done our initialization using a texture and a scale. So what I'm now going to do is I'm going to use the same thing, but this time I'm actually adding scale. And you'll see here that instead of setting scale to 1, I'm actually setting scale to be whatever is passed in. So pretty straightforward stuff here. I'm then going to start moving on and looking at the initializers with an image as well. So if I go in here, we can see that this time I'm taking a UI image as my input. And instead of texture just becoming a reference, I'm actually using texture 2D to allocate a completely new instance of a texture 2D object, and that will become my texture. And this is a bit safer than just using an external reference to a texture, because it means when I remove that particular image and I delete that image, it's actually going to remove the texture that goes with it. So I can't accidentally deallocate the texture associated with this image because it's inside the class it's been defined. So that makes it a little more stable from that point of view. It does obviously though mean that when you do destroy or delete this particular image, then you have to have a dealloc, and we'll deal with that at the end of this particular method. So you can see that, and this is really what we covered in our first tutorial, where we're actually creating a texture 2D, we're allocating to it, and we're using init with image, and the image we're using is the one that we've passed in. Okay, so this image here that we've passed in is the image which is being sent to texture 2D. Now, you'll also notice I've added actually an extra method statement on here as well called filter. So this is a change we'll have to go and make in a moment, but I've changed the texture 2D class to actually accept this filter argument as well. And that allows us to do the filter changes that I was talking about earlier. So here I'm saying by default I'm setting the filter to GL nearest, which will mean that everything is pixelated when you actually zoom up, so if it's larger. And also because I'm not defining the size inside the method signature, I'm actually defaulting the size to 1 as well. Okay, but we'll go and make the changes to texture 2D in a moment for this, so that we can cover off and see what it does. Okay, so we've initialized with an image. Now we want to be able to initialize with an image and also a filter as well. So if I pop in this one, you'll see it's exactly the same, except this time I'm taking a value here, which is filter, and I'm passing that through to my texture 2D allocation call as well. So the filter that I'm specifying is being passed through, really straightforward stuff. Scale is still being set to 1 because that's not something I'm actually passing in as an argument of my method. And finally, if I then go and get the next one, this is now, this is now going to be identifying the fact that I can actually pass in an image with a scale. Okay, so this time scale is being defined to the argument I'm passing in, and I'm defaulting back again to nearest, which means that the last one that really would be useful is for me to actually be able to pass in an image, a scale, and a filter all in one method call, which is what the next and last image init is going to do. Okay, so this time I'm actually passing in the scale and I'm passing in the filter, and I'm using both of them inside here. So there's my filter and there's my image scale. So that's our initialization done. So we can call those to actually initialize the image filter, and we can probably create some other convenience methods later on. But these are just handy because they do let you, depending on your needs for the image, create everything you want in a single method call and not have to create it and then do some setting of parameters afterwards. Now I mentioned, and as you can see in here, we've got this init implementation, which really means that outside of just setting this information, there's other info that needs to be set as well, like the texture width, texture height, texture ratios, and all those sorts of good things. So that's classed and covered, or sorry, that's not classed, that's covered underneath our init implementation method. So if I now place that particular method inside our class as well, okay, we can see here that this is where I'm doing some of the calculations we talked about earlier. So image width, sorry, is actually our texture, and I'm using the texture. Obviously, this is coming from a texture 2D object. So texture also gives us content size, and I'm getting the width of the content size. So inside texture 2D, content size is actually giving us the width of the real image, not the width of the texture, the width of the image inside the texture. So we want image width and image height to be equal to those. The texture width and the texture height is now equal to how wide our texture is in pixels, which are these two properties here which I'm able to use. And then the maximum texture width, okay, is basically the width of our image, which we've already defined, divided by the texture width. Okay, now that means then that the texture width is in pixels. So if this was 128 pixels wide, it would be 128 divided by the width, and that means that's the maximum texture width of our image. Okay, so that gives us that calculation. We're then also calculating the ratio as well. Okay, so we're saying that if this is the width of our image, and an image can only ever be 1 wide, between 0 and 1 wide, the ratio, in other words, 1 pixel of our image is equal to X number of pixels, and this is what is being held and calculated here. At the moment, I'm setting the offset of our image to be 0, so it's going to just be going from the bottom left-hand corner of our image. It's not going to be going and using an offset. Rotation is 0, so this thing isn't being rotated. And then I'm setting the color filter, and at the moment, by setting everything as 1, that basically means that it's going to be using whatever colors are in the image, and 1 for alpha means that there's no transparency. But that's something that we can change later on. Okay, now another little method that I'm implementing here, which is really just for testing and something that is quite handy for testing, is a description method. So what this is allowing me to do is, if I actually, once I've instantiated an image, I can then go and ask for its description, and that means I can get out some useful information about that particular image. So at the moment, what this will do, this will actually return a string, and that string is going to give me the texture ID, which is the texture ID used inside OpenGL, which is defined inside texture 2D. It's going to give me the width, the height, the texture height, the maximum texture width, and examples and so on. So it's really everything that we've defined up here, we can actually output by just doing a call to description, which is quite useful. So we can, if there are funny things going on, we can have a look here and see if there's some funny values that that we actually need to be dealing with. Okay, so what we now need to do is have a look at actually how we render things to the screen. So this is where it gets a little bit complicated maybe, but hopefully I'll be able to talk you through and it will make some sense as to what I'm actually doing here inside my particular method class. So what we're going to have a look at is how we can actually excuse me, render our image to the screen. And I'm sort of abstracting this a little bit to make the class a little bit nicer to use, and a little bit no repetition of code really as well. So the first thing I'm going to look at is it's going to be in order basically of the things that we've defined in our header file. So the first, if we go back to our header file actually, the first action method that I've got down here is about getting a sub image. Okay, so being able to return a sub image of what we've actually got. So that's going to be the method that we'll implement next. Okay, So I'll put in this particular method and then we'll run through it. Okay, so here's our method with the method signature that we defined inside of the header. So when you call this, we're returning a pointer to an image object, and we are identifying a point. So in other words, the point is where on the X and the Y axes within the image do we want to start taking a sub-image. And we then provide a sub-image width and a sub-image height. I'm using unsigned integers here, just because we always know that we're not going to be taking negative values, or in my particular implementation, I don't want to be taking negative values. I always want to be taking positive values for the width and the height. And also we want to be able to pass in a scale, which is a float, because it could be 0.5 or 1.5 or 2.7, whatever it may be. So once we've got those, what we do is we create a new instance of the image class. Okay, so we create this new image instance called subimage, and we allocate using that. Okay, and what we do is we're saying we want to init with a texture. Now this is where the texture side of things is quite handy. The image that we're currently in has already been initialized, and the texture property has been defined to point to the texture that we want, which is an instance of texture 2D. So what we can do here is we can actually create a new version of, or a new instance of image, passing in a reference to the texture here, which has already been created. Okay. Again, there's a risk here we need to remember, which is it means that this new sub-image object, which we're going to be creating and passing out, is referencing the texture inside this image. So if we ever destroy this image, it will destroy this texture that goes along with it, and that would then mean that we are destroying the texture that this new image object is using as well, and so there could be problems. So you need to remember that when you're creating images from other images, you need to actually remove the images in reverse order, so you don't end up with a bad alloc. So you're trying to access memory that's already been freed up because texture's been deallocated. We then have scale here as well. So this is where we are, if we want to, being able to pass in an image, a scale, which we are doing. So we've got the ability to pass in a sub-image scale, which could be 1 for the same size, or 2 if you want to double it up. So we're passing that in. So it's just really a very simple, we're allocating a new version of image using the current texture of the image we're in and giving it a scale. Once we've done that, we're then defining the offset. So remember, we've got this ability to define an offset inside an image, which is where the image will be drawn from, using then a width and a height whenever you ask that image to be drawn. So because we've got our sub-image, we're now going to set the texture offset for X and the texture offset for Y using the point values that have been passed in. So we can use the X and the Y point values passed in by getting our by the call to get sub-image at point. So that's now set the X and the Y offset inside this new image object that we've got here. We also can then set the image width and the image height, which we have here, image width and image height. And actually this has just reminded me why earlier on I didn't have those two items as being read-only. Okay, so we'll go and change that now so while I remember. So if we go back into image header, remember these weren't read-only and I changed them to read-only. The reason is that there are situations where I do want to change them externally, which is in this instance where I'm defining a new width and a new height for an image when I return a sub-image. Okay, so we'll just change that, save, and go back into our .m file. Okay, so we're setting the width and the height of the image in here, and we're then setting the scale of the image by using the setter for set scale. And lastly, we're setting the rotation of the image. And what we're going to do is we're going to set the rotation of this new image to be the same as the rotation of the image from which it's being taken from. We can change that later in the new image if we want to, but we're just we are respecting the rotation that's already been defined for this image and passing it back. And then lastly, we're just returning that. So we're actually handing that sub-image object that we've created back to whoever's calling it. And we now have a new image with a new set of properties for that image, but pointing to the same texture as was in this image. So there's no new texture being created in texture memory. We're not using up any more memory in that respect. We are just referencing the texture that's inside this image. But we can now do different things with that image. We can have different rotations, different sizes, different locations, different color filters, without affecting the image from which the copy was taken. Okay, so that's quite useful to be able to do. Okay, so that's being able to get a sub-image from our image class. We now need to be able to handle rendering an image. So we want to say, there's an image, render it to the screen at a certain location. So that's really our next method, which is going to be the render at point method, which I'm going to pop into here. Okay, so this takes two arguments. We've got the point, which is the x and the y coordinates of where we want to render it on the screen. And we then have the center of image argument, which, as we said, if we have yes being passed in, it means that this point will be treated as the center of our image, and that's where it will be rendered. If we pass in no, then this point will be treated as the bottom left-hand corner of our image, and that's where it will be put onto the screen. So as part of rendering the texture, we want to basically pay attention to the texture offset x and y, because remember, we could be rendering an image that has an offset. In other words, we're not rendering the entire texture that this image points to, we're rendering just a portion of the texture that this image is referring to. So we create a new CG point, and the x and the y is basically using the texture offset for x and the texture offset for y. And then we're calling this other routine here, this other method called render sub-image at point, and this is the next method we're going to create. And it's good because it means that we can call this either directly if we want to render something to the screen, or we can call it from within the render at point, passing in the values as necessary. So we're basically limiting the number of methods that are actually rendering stuff to the screen, so that when we need to make a change to the render code inside here, we only have to go to one place. And whether you're doing a render sub-image or a render at point, it's all in effect going to be using the same piece of code. Okay, so it just keeps things nice and tidy. And what we're doing to render a sub-image is we're passing in a point at which the actual image will be rendered. We're then passing in the offset, okay, which is the location within the image that we want to actually take the texture from, the sub-image from. And that's this point up here that we have just created. And we're then defining the image width and the image height, and also whether it should be centered or not. Okay, and again, center is being passed through as one of our options that we're putting inside the method here, one of our arguments. So pretty simple method, but obviously it doesn't work without the render at sub-image method, which is the next one that I'm going to put in. Now this has got a little bit more in it, because we're getting closer now to actually rendering to the screen, so there's a bit more information we need to be calculating in here, so it's a slightly larger method. So if I pop this method in, okay, you can see it's a slightly bigger method that we've got here, and what we're doing is we're taking in all of these things that we've just run through, the point at which we're drawing it, the point at which we want to start taking a sub-image, the width and the height of that sub-image, and also whether we want to render centered or not. And this is where we're actually starting to do a little bit of maths to calculate what the texture coordinates are. So remember that I said that when we actually draw something in OpenGL for our needs, we set up basically two arrays. We set up one array which holds the coordinates of our texture, and we set up another array later on which holds the vertices for our quad, in other words the shape in which we are drawing our image. So for each of these we have an x and a y coordinate for each of the 4 points. So because we're drawing a quad, okay, it's got 4 points, we need to define the 4 corners of the texture that we want to actually place within our quad. And that's what we're doing here. So I'm creating a brand new float array called texture coordinates, and inside that I'm defining each of the x and y coordinates for them. So we have 8 altogether. So we have x here, so this is our first x point, and then we have our first y point, and then we have our next vertices is going to be x, and then we have y, and it goes down to the second line there, and then we have x, y, x, y. Okay, now what you can see here is I'm using the things that we've defined as part of the image to calculate where we need to go and grab the texture from. So I'm saying the texture width ratio, this is how many text cells are represented by 1 pixel in our image, is multiplied by the number of the sub-image width. So how many pixels wide is our sub-image to be, and I'm multiplying that by the text cells, and that gives me a texture coordinate inside our texture, because it can only be from 0 to 1. So this will give us a texture coordinate. And I'm then saying, well, that's fine. So I want, that's the width, but where do I want that width to start from? Well, that width starts from the offset point. Okay, and you could have this calculation the way around to maybe make more sense, but this is the way I've done it. So there, again, we say we want the texture width ratio multiplied by our offset point x. So x is how far into the image do we want to start taking our texture, and width is then how far from that point in do we want to actually take it. So it's fairly simple maths. We're just working out the actual coordinates in texture coordinates, and texture coordinates can only be a value from 0 to 1 maximum, and we're identifying them for each of the points on our quad. So I do the same for here. So I do the same for texture height ratio times offset. Okay, so you can tell here, you can look at this calculation and work out the point that I'm actually working to, because I'm taking the width here as well as the x offset, but from here I'm just taking the y offset. You can see that I'm doing this is giving me a calculation for the bottom right hand corner of our texture. So I'm actually saying the bottom right hand point in our texture is located here. Because I'm not looking at the height of the texture, I'm just taking the base Y position of the texture. The next one says I'm now going from the bottom right hand corner, okay, which is X, which is the width of the sub-image we want, all the way to the height of the sub-image. So I've got height in here now. Okay, so this top line was the bottom right hand corner of our image. This is now the top right hand corner of our image. Okay, that's what we're calculating there. We then go from the top right hand corner of our image down to the very bottom left hand corner of our image. Okay, so we've drawn a triangle, basically, if you can imagine. We've done our bottom left hand corner. Sorry, we've done our bottom right hand corner. We've now done our top right hand corner, and we're now going to do the bottom left hand corner. Okay, and if you sort of draw that on a piece of paper, you'll see that that does make a triangle. And the reason is that we are later on going to be using something called a triangle strip, which is because of the way that OpenGL ES works on the iPhone, we're going to be drawing all of our shapes using triangles. So to draw a square, you have to make 2 triangles basically, but you can do that with just 4 points, as we're doing here. So we go bottom right, top right, and then bottom left, okay, and then by going from bottom left to top left, which is what this calculation here is doing, okay, that is enough of an information for OpenGL to understand what the 2 triangles are, and it will know that's a square, and it will map the texture on that accordingly. That sounds a bit complicated. I've maybe not described that as well as it could be described, but if you go onto the Nihi site, which has a link from tutorial 1, you'll be able to see probably a better description as to how this texture mapping stuff works. But that's what we've done. We've now identified within our big texture the coordinates of the bit of the texture that we're interested in. Okay, that's going to be the same whether we're taking the whole texture or a sub portion of the texture. Because we're using these items like sub-image width and offset point, if there was the width was the full width and the offset point was 0, we'd be looking at taking the whole image. Because we can also define sub points, we can take smaller parts as well. So we're just using the same piece of code whether we're taking the whole image or a sub part of the image. The next thing we need to do is we need to calculate the vertices or the points for our actual quad, the actual box inside which that image is going to be mapped. So to do that, we need to work out the width and the height of our quad, and we're doing that by taking the sub-image width again, and we're multiplying that by the scale. So this is how we're doing a very simple scale. We're saying whatever the width is, multiply it by the scale, and that will either go up or down. We're then, within an if statement, just here, creating another float array of 8 points, okay, just like the one above for the texture coordinates was 8 points. This is 8 points, so we've got each point of the each point is x and y, and we have 4 of them inside our quad. What I'm doing here is I'm saying if center has been set, in other words, if center of image, if that particular argument has been defined as yes, that means we want to have the quad or the square of our shape, or the shape in which our image is going to be drawn, sorry, to be centered around the point that was provided. So what I do is I basically on here say for the first point it's going to be the quad width and the quad height, okay, divided by 2. In other words, we only want it half, so this is the divided by 2 is just giving us the center. So the quad width and quad height is actually defining the top left hand corner of our quad, okay. So quad width and quad height is giving us the top right hand corner of our quad, okay. Now we're then moving on to point 2, which is saying quad width again, okay, except this time it's minus quad height. So this is giving us the bottom right hand corner of our quad, okay. We're then moving on and saying it's minus width and positive height, so that gives us the top left hand corner of the quad. And then last of all we have minus width and minus height, which gives us the bottom left hand corner of the quad. Because we're obviously working in OpenGL space here, and we've defined earlier on that the viewport of our game is orthogonal, and we've really specified that 1 point in OpenGL space is equivalent to 1 pixel, okay, and that's why we can do this quite happily. If you're working in 3D, then again you'd have to work out, well, how many pixels in screen space are represented by 1 unit in OpenGL space, and that stuff took me a while to get my head around. So again, looking at the Nihi early tutorials is quite good for getting your head around how some of this stuff works. But what it's really doing is it's saying I'm going to use the quad height and the quad width divided by 2 to make sure that the point at which I'm rendering my image is in the middle of the square, and that allows us to do that. If you don't center it, then we're not worried about doing this minus stuff, okay, because we just want to have everything drawn from the bottom left hand corner. So we go literally from quad height and quad width, which is going to be the top right hand corner, to quad width and 0, which is the bottom right hand corner, 0 width and quad height, top left hand corner, and then 0, 0, bottom left hand corner, okay. Take some time to get your head around that, because that can be a bit confusing, but once you have got your head around it, it actually does make a lot of sense. I'm just probably not describing it as well as it could be described, so apologies for that. So we've now got 2 arrays. We've got our coordinates. We know where inside our texture we want to go and grab our image from. We know the size of our quad and where we want to render it. So now it's a case of actually going and rendering that, okay, and for that, we run this render at method, which is going to allow us to render. This is actually going to do the real work now. This is going to do the OpenGL work to actually render this information to the screen. And that's going to be the next method that we move to over on this tutorial. So what I'm going to do here is just paste in the render method, and we'll start working our way through it. So the render at method is the actual method that really does render to the screen. It takes the 2 arrays that we've created. It takes the texture coordinates array, and it takes the quad vertices array, and it also takes the point at which we want to actually render these to the screen. And we then actually go and use the OpenGL to do this. Now, there are a couple of things that I've changed here from tutorial 1. Which we're going to go and sort of finish changing in a moment. But in tutorial 1, we, in the initialize the init with coder method, we actually defined a lot of the OpenGL parameters, like the client states, we defined the texture bindings, we defined a whole bunch of different bits and pieces. Having done a bit more reading, it's probably best to not sort of set that once globally, because for example for blending, blending is quite an intensive process, and so you only want to really have blending switched on when you really need it. So it seems that the good practice is to actually only switch on certain parameters and certain values in OpenGL when you need them, and then switch them off afterwards, so that the next item being drawn controls itself in terms of does it use blending or does it use any kind of transformation, etc. So We're going to be removing some of the GL configuration in that init with coder, and we'll go and do that in a moment. But it does mean that obviously I've moved some of it into this method here, so that every single time an image gets drawn, we define the parameters necessary to actually draw the image as we require it to, with blending and so on. So what we'll do is I'll just start to move through the code that we've got here. And the first thing you'll see that we're doing is we've got this GL push matrix. GL push matrix really saves the current matrix that is being used in terms of translation, where are you on the screen, rotation, and so on. So that if you push something, or if you push something to the GL stack, it's saving that matrix, that transformation matrix, the current transformation matrix. And then later we can pull it off the stack, pop it off the stack, and it returns it to where it was. So it's quite handy because it means that we can say, well, I don't really care what's gone on and what other things are doing, save all of that, then go and translate to where I want to draw my image and bind my texture and draw my image and change my colors. And when I've done all of that, I'm then going to go back to the state it was before the image was drawn, so that the images end up being separate from one another. They don't interfere with each other in terms of rotating and translating and things like that. So that's why I'm saying save the matrix as it is, in other words the current configuration of the screen, etc., and then start doing the image work. So that's what push matrix does. When I've done that, I then issue the translate command, and what this takes is the point that has been passed in, and it takes the X, the Y, and because there is no Z plane, there is no in and out of the screen in 2D, I'm setting that as 0. So it really translates the viewport and specifies the point at which I'm going to start drawing from as being the point in which I've actually passed in as one of my parameters in this particular method. So I move to where I'm actually going to be drawing my image. I then issue the rotate command, and the way that I'm rotating and the way that the rotate command works is that it takes an X, a Y, a Z amount. Yes, that's right, sorry. We change that. It takes a rotation amount, and then it says, am I going to be applying this rotation amount to the X, the Y, or the Z axes? Okay, now I've got the rotation as a negative here of whatever is sent in, so that if you send in 45 degrees, it actually rotates right 45 degrees. If you send in a negative value, it will rotate to the left. So I added a negative here just so it was going clockwise with a positive degree of rotation. If you set 1 in each of these areas, so 1 for X, 1 for Y, 1 for Z, it would rotate in that space. It would actually rotate around all of those axes, okay? Rotating all of them at the same time means you can end up with something called gimbal lock. I don't really know enough about it to explain what it is, but again, it's something you can look up if you're worrying about it, or you're wanting to use it, sorry, inside maybe 3D work. But for 2D, if you're looking at the screen and you want to rotate around a single point, the actual point you're rotating around is on the Z axis, in other words, in and out of the screen. You're not rotating Y or Z or X, you're rotating Z. So I'm basically saying rotate this angle around the Z plane. Okay, so it rotates the whole screen to do that. Now remember, I've saved everything else on the screen, so that's not going to be affected, the matrix for those. So I'm saying rotate the screen and then pop back on our image, and then I'm going to rotate the screen back to where it was for everything else to be drawn once this image is done. I then set the color. So remember, we've got this color array with red, green, blue, and alpha, and it's a 4F, so it does take the 4 points, the GL color call here. So I just literally go and pull the value from each of those array elements and pop them into color, and that really allows us to tint. So whatever color you put in here, it will tint the color of the object that you've got. Again, there's far more information on the internet about how the tinting works, how the blending of colors work, and so on. So definitely, again, Nihi's got information on that, so worth a look. The last one here being alpha. So again, you could keep all of these as 1, 1, 1, which means there's no real effect to the color at all, but you could set alpha to 0.5, and that would make it 50% transparent. So we set the color, ready to do the drawing. Okay. We then enable a client state here, and this client state basically saying, because we're passing in texture coordinate array, it's saying we are going to be using a texture coordinate array, and I want to enable that to happen. So it's really saying that OpenGL can handle an array of texture coordinates. We're then switching on texture 2D, GL texture 2D, so we're saying we're going to have a texture that we're going to want to apply to our image. We then bind our image, so we want to make sure that the image we're about to use is the image of, or the texture, sorry, we're about to use is the texture inside the image we're currently in. So we can take the name of the texture as we do here, and that's the OpenGL name as created and stored by the texture 2D class, and we can bind it. So we know that whatever we're about to do, it's going to use that texture to do it. We then say, okay, we now need to set up the quad vertices. So we set up this thing called vertex pointers. And this is used when you've got an array of vertices that you want to draw, okay? And this is how we're going to basically draw our quad on the screen. The things that are in here that are of interest, 2 means we're going to be taking 2 parameters, which is going to be x and y. If you're in 3D space and you had an x, a y and a z, you would say that each of these that's important is 3. So it'd be three locations within the array will be taken x, y, z, x, y, z, x, y, z, and so on. And we're saying the next argument here is defining the fact that each of the values inside the array are going to be floats. And then the last one over here is defining, this one here is an offset. Are you starting from the beginning of the array, or do you want to start from 2 into the array? So you can define an offset into the array you want to start the drawing. And then we actually say, and that's the array itself. So that's the array I want you to go and draw. Okay, from a vertex pointer point of view, which is the shape that we're going to draw. We then do exactly the same, except we use a texture coordinate or text coord pointer, and the same values, and it does exactly the same thing, except this time it's actually the texture coordinate. So this is saying these are the coordinates for the points that are going to define my shape. Text coordinate saying these are the points that define the location within the texture that I want to map into that shape. Okay. We then say we want to blend, so we want to be able to blend this onto the screen so that it handles things like alpha. So if you want to set the alpha of and the color of something, you need to be able to blend it. So we're switching blending on. Okay. And then lastly, we're actually doing the draw arrays. And this is saying, well, we've got our vertex pointer and we've got our texture coordinate pointer. We've set up here this text coordinate array, so we know that texture coordinates are going to be important and used inside this draw arrays call. And we're then saying, and we're going to be using triangle strip. So this is what I was talking about earlier, where you actually are defining all of your shapes using triangles. And it's important because OpenGL ES doesn't support GL quad strip, okay, which would mean you define everything in quads. It only supports, for this type of work, triangle strip. So you define everything in triangles, okay. And so we're defining the fact that that's the actual technique we're going to use. Then there's an offset, and we're saying that we've got 4 points inside our arrays. Okay, so we've got 4 locations in the arrays that we're actually going to do for the 4 points that we're going to be reading from our arrays that we defined earlier. Okay, so again, I hope that makes sense. That's maybe not been described in the best possible way. Nihi and other websites do a really good job at letting you understand the basics of how all this OpenGL stuff hangs together and works. But I've given you a rough idea there. So this command is actually what physically draws the texture, the shape, and blending and everything to the screen. So that's now drawn. So because we're finished, we can then say now turn off blending by using GL disable. We can then turn off the texture 2D because the next operation may not want to use textures. And we can then turn off the texture coordinate because again we may not want to apply texture next time we use draw arrays, so we're switching that off. And then lastly, we are popping the matrix. In other words, what we saved earlier on with push matrix, we're now popping, so it's going to return us back to the location we were before we did our translate. It's going to turn us back to the rotation we were before we did our rotation, and so on. So we've got a nice little self-contained unit there which says draw this to the screen, sorry, save the current settings, draw our image to the screen with its settings, and then revert back to the previous settings. Okay, and that's really it. So this is what I was talking about we've got one routine here inside this method, this render at method, that does all of the actual OpenGL to render to the screen. And then that's being called from within inside our, if we go slightly up, our render subimage at point, which defines the texture coordinates and the quad coordinates or quad vertices, and that in its turn is actually being called by render at point. So you can either call render subimage at point directly if you know of the size and the type of subimage you want to draw, or you can actually just say render the entire image and it will use the configuration inside the image to do that rendering as well. But the code is very straightforward. We only have to make changes to render subimage at point if we're changing the texture coordinates or the quad coordinates, and we only have to go and make changes at render at if we want to change any of the OpenGL. So I think that's fairly clean and sort of works quite well. So we'll save that. So that's really given us our method. We've now got our new image image class, which we can start to use. So at this point, I'm going to compile this just to make sure everything compiles okay, which it doesn't. We've got a few errors here, so let's go and hunt these down. Okay, so if we have a look, we've got an error here just before the texture 2D stuff, which we'll have a look at. Right, and what we can see is that I've actually got a missing import from here because it doesn't know what texture 2D is, because we're actually using that. So I'm going to add an import here for our texture 2D. Okay, if we build again, okay, we can see that we've got a number of warnings here. Okay, may not respond to init implementation. All right, now the reason for that is that there's something else that I've forgotten here. So this has jumped back into our initialization routines, and you can remember we had this thing called self init implementation, which we have created, but we didn't actually define it in our header. So if I flick back to the header and scroll down, you see we didn't actually define that inside our header, and that's because it's private. It's something that we don't want to expose externally. So what that means is that we actually want to go and create that implementation, or that header if you like, internally inside our class. So what we can do is, if we go back into our image class here and go back up to the top, there are basically some private methods that we want to create. So I'll quickly add these here. So if we say private methods, okay, and we add an interface like so. Oops, in fact, I don't want to do interface, and this is going to be for image like that. Right, and we want to add our void init implementation. That's the one we need. There's nothing taken there. And the other one we can add here as well is also going to be our render at, because render at isn't one that it's an internal one that we use. It's not exposed externally. So we can actually define that here, which was render at, and we had a CG point, which was going to be point. Oops. We then had text coordinates, which was going to be floats, and it was going to be a float array. Okay, so we'll put the square brackets there, and that was coordinates. And then we had quad vertices, which again was a GL float array, and we called that vertices like so. Okay, and we can then finish that off with an end. Okay, so if I now build that, oops, I've got another little mistake up here. Get rid of that bracket. Okay, so what you'll see is we've got another couple of little arrows here, and this is because there's two classes that we haven't yet finished adding to our method. So that's fine, we can quickly go and add those now. If we look at the header file, these were the setters that we actually had at the bottom here, which I haven't created yet. So if I go back into the M file and we go all the way down to the bottom, okay, and we can add these extra two classes in that we need. So what I'll do is I'll just put these all in one hit. There we go. Okay, so these are very simple ones. This is set color filter red, so it takes 4 floats, one for red, one for green, one for blue, one for alpha, and all it does is it goes and defines or sets the necessary filter array that we had defined with those values. And as you saw earlier, inside our drawing code, we used GL color to be able to define the color using those parameters. And the other one which we did was set alpha. And again, so this is where I'm actually just setting the third or fourth, as it is, value in our array to be the alpha value. So very straightforward. So if we now actually compile that, we succeed. So we've actually now got our image class in running, not running, but working. It's compiling okay, we're not getting any errors. But there are a couple of things that we now need to do inside our texture 2D class to actually make sure that we're getting the filtering right. So earlier we talked about the fact that I've added some extra bits to texture 2D to handle filtering, which if I go back up, where are we? Have a look to the init. Here we go. You can see that we were passing in a filter, and that when we actually implemented the texture 2D, it was able to take a filter value, which it wasn't able to take out of the box as was. So we need to basically go into texture 2D and we need to add that to it. Okay, so what we'll do is we'll bring up the texture 2D header file here, and we need to go through and we need to identify where we are actually needing to do that. So if we have a look through this, we'll see that one of the key things inside the header file here, if I scroll down, we've got texture 2D, we've got init with image, okay, and we pass in an image, but we actually need to pass in a filter as well. So this is the first thing that we need to change. So if I put in here filter, it's a GL enum, remember that we're going to be passing in, which is GL nearest or GL linear, and I'm going to call that filter. So we've done that at the init with image level, which we needed to be able to do. Now if we go a bit further up, we'll also see that there is an init with data. This is an internal, this is called internally inside GL texture 2D as well. Oh, sorry, texture 2D as well. So we need to make sure that this can take the filter. So GL enum filter will pop in there. Okay, and that's pretty much it. We don't need to add anything else to that. So we'll save that, and we'll then go into the actual implementations themselves. So in here, I'm going to use the drop down. I want to find the init with image implementation, which is just here, and we need to add filter to this. So if I say filter GL enum, and we're going to call it filter. So we've added that in there. We know that that's going to be passed in now when we actually do that piece of work. So there's nothing else there that we need to do. Apart from, if we go further down inside that particular init method, so if we scroll down, we'll see right at the bottom, it actually calls, here you go, init with data, all right? And init with data, again, we need to be able to pass in, because the actual filtering doesn't get defined inside this method. Init with data does the real work of defining the image. It just gets called by the init with image if you're passing an image in rather than data in. So we need to add the filter to this as well. So if I add at the end here, the fact that we're going to be sending in the filter information. Okay, this passed. So what we'll do is we'll say filter, and it's passing in filter. All right. So that's that done. And I'll pop back up to the init with data, which is a bit further at the top. Here we go. And we can see here's the method signature. So again, we need to add a filter to the end, GL enum filter. Okay. So that's changed the actual headers there. So if I save that and do a build, okay, we can see we've done that, and we've got one warning. Let's have a look here. May not respond. So let's go to where that is. Okay, and that's because we've got that's actually inside the init with text, I believe. We go, yeah. So there's the init with string. So again, if we're doing that, we would need to pass in a filter. For what I'm going to do for this one is I'm actually going to just say filter GL underscore linear. Okay, so I'm going to just hard code the string side of things. We're not really using that at the moment, to always use the linear filter. Okay, so I can save again, and I can build again, and that's got rid of the errors that we had there. So if I go back up to the init with data, here we go. So what's happening is this is really where the filtering is being defined, and the filter is being passed in now. But what we need to do is we actually need to make use of that filter, and where we do that is in these commands just here. Okay, you can see at the moment linear is hard coded in there as the filter which is being used for the textures. And there are two types of filter. You've got a texture minimum filter if we're scaling down, and a texture mag filter if you're scaling up. And I want them both to be the same, and I want them both to use filter. So what I need to do is I'm going to change that to say filter. I'm then going to copy and paste this line here, and as I said before, min is 1. The other one we need to make sure we cover is mag. So if I do mag filter, there we have it. So save and build, and that works. So that's all we needed to do. We just needed to make those small changes to make sure that when we actually create a texture 2D object, we can pass in the filter, and that the filtering will be used inside those particular objects themselves. And that's now what we've done. So we're really at a point where we can have a go at trying this out. We can try and play with our image and make sure that our image class is actually working and actually doing something. And also make a couple more changes to the actual main view that we're using. So if we go into the EAGL view, this is, remember, where the core game engine is being run, if you like. If we scroll down, in here is where we've got init with coda, which is called when the application is first run. And in here is where we're actually using and defining a number of different items around OpenGL that we aren't going to need all of them. So, for example, GL blend, that's being defined inside our image class now, so we can remove that. The blend function will stay here because we want to send a global blend function for our needs at the moment. Texture 2D, we don't need that. We're setting that within the image class itself, so that can go. Depth testing, we want to disable depth testing because, again, that's just performance hogging that we don't need because we're not in 3D, so we can leave that within this init. We can also leave the texture environment side as well, so that can be handled in here. And the vertex array, this is saying that we're going to be passing an array of vertices into the drawers array, which we are. I think for all of our purposes at the moment, we're going to be doing that. So we can leave that at a global level. But the texture coordinates, we are defining that again inside image, inside our render at methods. So that we can remove, okay? And then we have just the GL color, which we can leave. That's the color we're clearing the screen for each time. So we can leave those items as they are. No need to change any of that because we're doing everything else we need to do inside the actual class itself. So the next thing we need to have a quick look at is just to be able to, for example, set the viewport that we're going to be using as well, because we've set up the orthogonal side of things up here. Okay, one thing we do need to be able to set is we do need to be able to set the viewport, which is for our game, which is going to be the size of the screen, so that we actually get the size and the scale correct. So what I'm going to do is I'm going to add GL viewport in here, and you can see the X and the Y coordinates. So we're going to say it goes from 0, 0, and it moves along, and it's to rect. Oops. rect.size.width, and it goes from there to rect.size.height. So they are the things that we're going to be doing in terms of the viewport, and we can cover that off, save again, and build just to make sure that everything is working okay, which it is. So now what we can do is we can actually start, rather than using our texture 2D image, we can start to use our image class image, and we can do that by deleting this, and we can then start to use the image class that we've just built. Right, so we had player ship there, so if we have a quick look inside our header, player ship is actually down at the moment as being a texture 2D, which we don't want, so we want to make that image. So to have that work for us, we need to go back up here, okay, and we can leave texture 2D because maybe we want to create some of those directly ourselves, but we need to make sure we're importing our image class as well, which we have there. Save that. Okay, so we come down and I'm going to change image texture 2D to become image. So now player ship is going to become an instance of image. So save, go back to our M. So what we can do now is we can actually start to create a new version of this. So we say player ship equals, and it's image, and we're going to allocate, and this one we're going to do init with image. So we create a new UI image, UI image, image named, and it's going to be player.png. So we're going to use the same ship that we had last time, and what we'll do is we'll use the filter on this one. So I'm going to go filter GL nearest, like so. So that's created our ship. That's pretty much it. That's all we need to do. If we go down and actually have a look inside our draw routine or our render scene routine, okay, we're doing player ship draw at point, which is going to change now. So if I get rid of that, it's going to be render at point, and we can say CG point make, and we're going to again do 140 across by 240 up, and we're going to say center image yes. So this is, as you can see now, starting to use the methods that we had in our class. So I've done that. So if I save and build, and that builds okay. So if we try and run this now, we get our image on the screen. Okay. But that's pretty much exactly what we had last time. So let's try some of the other options that we've got. So going back to our main routine here, if we go back up to where we define the player ship, and what I want to do is I want to rotate it. Okay, so I can say player ship set rotation, and I want to rotate it 45 degrees. Okay, that's all we need to do, and I run again. And hey presto, we've got it rotated at 45 degrees. And so that was pretty straightforward. So we've got the rotation side of things working now. So again, I'll stop that and go back in here. And what about, we want to scale it as well. So we'll say player ship, and we'll say set scale, and I want it to be 4 times bigger than it is now. So we'll do that, save and run again. Whoa, and we got a big ship. So we know the scaling and we know the rotating is working, which is cool. We may now want to set the color as well. So if we come back out and into here again, and I can this time set the color. So again, we'll say on the player ship, I want to set the color filter, and I want red to be, I want it to be a real red filter on here. So we'll make it red, and the others are going to be zeros, and it's going to be fully opaque, so we'll do that. Okay, let's run that again, and there we've applied our red filter to it. So we've done a lot now. We've got an image class that is going to allow us to scale, rotate. It's also going to allow us to apply color filters. If I come back out of here again, and this time I actually put in here something like 0.5 and run it again, that should give us some transparency. So it'll be slightly transparent, makes it a bit darker like that. So if I again back out, now we talked about the filtering. If I was to change this from GL nearest to GL linear, and to run this again, okay, you can see that's an awful lot smoother than it was before. So let me just get rid of this color filter here for the moment, and run that so that we haven't got the color filter on it. There we go. So it's a little bit blurry, but you can see there's none of the pixelation that we had before. And if we want to compare that, we could actually create another version of our image. Okay, so if I go back up to the header, and I say I've got something called image player ship 1, or in fact no, let's do something. Let's do this. It's going to be player ship 1. Okay, so we save that back into here, and what I'm going to do this time is I'm going to make a copy. So I'm actually going to say that player ship 1 equals player ship, okay, get sub image, Okay, now I want to take the entire, I want to copy the entire thing. I don't want to have anything smaller than that. I want the whole image. So I know the size of the image, so I can say the point that I'm going to take that from is going to be CG point make, and I'm going to go from 0 to 0. The width is going to be my 48 pixels, because I know how big the image is. Height is going to be 71 pixels, and scale is going to be 1.0. So I want it to be the same size that it was before. Okay, so that's now giving me a copy of my player ship, and I can now do different things to it. So for example, I could say player ship 1 set rotation is going to be 123 degrees, something like that. And if I then move down to the rendering part where I'm drawing my scene, sorry, I can now say player ship 1 render at point, scene point make, and this one is going to be at say 50 by 50, and it's going to say, yeah, I want to draw it in the center of the image. And if I now draw this, okay, I've got my two images. One is a copy of the other, but you can see that my second image is rotated and is scaled differently to my first image, even though they're referencing the same texture in memory. Okay, so that's allowing us to be able to do that and to be able to have different things that were on here. If we wanted to see the difference in terms of the colouring as well, I could quite easily go up, and I go back up to the top. If I set this to be all ones, oops. So let's uncomment that, and I'm going to say I don't want to change any. In fact, no, sorry. Let's actually use the method that we created. So if I do player ship set alpha, and I'm going to say I want it to be half transparent. Okay, and if we draw this ship directly underneath it, okay, we'll see that the transparency is working. Of course it will be working because it's actually drawn over the top. Okay, because obviously the sequence in which I'm drawing these things, it means that this image is being drawn on top of this image. So if I just swap these things around here and run that again, there we go. We can see that we can still see the image through it because we have opacity. So that really sums up this particular tutorial. I know we've covered an awful lot in this one, and it's going to be quite a long tutorial to watch through. The source code for this is all posted on the blog, so download it, have a play, have a fiddle around, and if you've got any questions, post them, and I'll get back to you on those. The next tutorial is really going to be saying, okay, we now have this base image class, and with that we can now start working with sprite sheets and accessing things nice and easily inside a sprite sheet. We can also start to then think about animation, which will be the following tutorial from that. So I'm hoping the next set of tutorials are a little more rapid than it's been between the first and this one. But I hope you enjoyed that. I hope it's made some sense to you, and I look forward to coming back with the next tutorial soon. So thanks very much.